Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss and focus on one of the interesting topic that is all about the smart materials. It is one of the subject in engineering chemistry. Under engineering materials, we are going to discuss about these smart materials. So we are going to focus on what are smart materials and what are the applications in especially in engineering field, and what about the shape memory materials and polylactic acid we are going to see in detail today. Coming to the smart materials. The smart materials have properties that react to change in their environment. So these materials will change in their structure or in their temperature. They will react according to the external environment. This means one of their properties, like by an external condition such as temperature, light, pressure, electricity, voltage, pH, or chemical compounds, they change according to the external environment. This change is reversible. So once this change, suppose if we are taking one material, upon heating, it may cause change in structure. Again cooling, it may reversible, means it retains its original shape. So these reactions are reversible and they can be repeated for many times. So these materials play a crucial role in various engineering applications because of these unique properties. These are intelligent and responsive materials. Are designed materials have one or more properties like temperature or pH which are reversible, can be significantly changed in a controlled fashion by an external stimuli. External stimuli means such as stress, moisture, temperature, light, etc. So these materials will respond according to the temperature, pH or light or moisture. So they will respond and the response will be reversible. So which can be repeated for many times. So these are the smart or intelligent materials. So these materials are again different types like shape memory alloy, pyroelectric, electrostrictors, magnetostrictors, electrochromic, piezoelectric, thermoresponsive, chromic, magnetoresponsive and piezoelectric. So the piezoelectric means it is like due to the mechanical strength or electric current. So this is mechanical strength. Electrochromic means there will be a color change. Magnetostrictors means change in the magnetic field, and electrostrictors means electric polarization will be differed due to the mechanical strength. These electrostrictors and magnetostrictors are, this mechanical strength results in the electric polarization or change in magnetic field, and pyroelectric is electric polarization, and shape memory alloy is due to the temperature change. These are all external stimuli. This is the resultant. So due to the application of the temperature, the shape memory alloy retains its mechanical strength. So we are going to see in detail in every step. What the first thing is piezoelectric smart materials. So this is the classification like piezoelectric materials, shape memory alloys, magnetorestrictive alloys, and electrorheological or magnetorheological fluids are smart polymers, and thermochromic and photochromic materials, and final one and the last one is all about the hydrogels. So we are going to see first thing about the piezoelectric materials. So the piezoelectricity was discovered in 1880 by Curie brothers in quartz crystals. So here the smart materials are quartz crystals. How it was going to work. So they produce electric energy upon application of mechanical strength. So we can see this is the mechanical strength is applied. So this causes the electric flow. So the electric current or electric energy is produced upon the action of the mechanical strength on a particular material. So the commonly known piezoelectric material is quartz. So the mechanism involves development of electric charge due to the movement of electron on application of stress. How it happens means when the mechanical strength is applied on the substance, the flow of the movement of electron causes the electric charge. This causes the mechanism. This is the mechanism involved. So the flow of electric current causes the substance to move, or to this electric charge is developed due to the movement of these electrons or upon the action of strength. Here if we see the piezoelectric current, when it was pressed, our mechanical strength is, this is the common example, like this mechanical strength is applied in the lighter. This is the lighter. This is the electric, mechanical strength. So the piezoelectric element is this material is piezoelectric material. When it was pressed, our mechanical strength is applied. The movement or the flow of electric electrons causes the electric current, which causes the lighter to light up. This mechanical shock is converted into the electricity. So this is the common example of piezoelectric materials. So we are using this smart material inside the piezoelectric element inside these lighters. Coming to the applications of piezoelectric materials, it is used in sensors and actuators. So the sensors, usually the sensors for pressure, acceleration and force measurements, as well as in actuators for precise movements in devices such as inkjet printers. So in the inkjet printers, for the precise movement from left to right or right to left, these smart materials, and they are used in sensors for pressure, acceleration and force measurements in instruments. Energy harvesting. They convert mechanical vibrations into electrical energy for powering small electronic devices. For the small electronic devices, these materials actually convert the mechanical vibrations into the electric energy. So the best example and the common piezoelectric material is quartz. So the quartz crystal, and this is topaz, tendon, dentine and enamel material. These smart piezoelectric materials are used, and sugarcane, bones, these are the natural piezoelectric materials. The next type of material, smart material, is shape memory alloy, which is also called SMA. A shape memory alloy is an alloy that can be deformed when cold but returns to its pre-deformed shape when heated. Means this is the original shape of the shape memory alloy. When some external stimuli or force or stress is applied on the alloy, it deformed shape. So it changes in its shape, and when it was heated, again it will comes to its original shape. So this is the shape memory alloy. So it depends on the temperature. So heating, we are heating means we are increasing the temperature, and to retain its shape we are cooling the temperature. To deformed shape we are applying the pressure. So it purely depends on the temperature. So what are the engineering applications? So the biomedical devices used in these materials, shape memory alloys, are mostly used in biomedical devices. They are used in stents, used in compressed for insertion and then expanded to their original shape within the body. So if it is a nerve, so to replace to have the stents in the blood vessels, so the materials will be very small and they are inserted to a certain area of treatment, and once they reach the site where we have to place, then it expands according to expands to its original shape in the body. So this is the stent. It will like a mesh. So it was allowed to pass through the blood vessel. Then after entering into the certain point, it was allowed to retain its original shape and it will expand. So this is used in this biomedical uses of smart materials or shape memory alloys is stent. And coming to the aerospace, some deployable structures and adaptive wing components in airspace applications. So actually, due to this climatic conditions, when some obstacle came, the these wings has to get deformed shape, like the deployable structures and adaptive wing components to have that, to retain it, to have some deformation in the structure. these smart materials are used. So even here, so this ordinary wing here, this is a muzzle wire. So do this shape memory alloys are used because it was retaining its shape, again it was opening. So this is about the shape memory alloys. It is also used in medicine, optometry, engines, aerospace, robotics, automotive, pipings and civil infrastructure, water sprinklers and textile industries. The next smart material is magnetostrictive materials. These magnetostrictive materials are used to convert electromagnetic energy into mechanical energy and the reverse, like magnetic to electric and electric to magnetic energy, electromagnetic to mechanical energy and mechanical to electromagnetic energy. This effect can be used to create sensors that measure a magnetic field or detect a force. These materials change their shape in response to the application of the magnetic field. So the response of here we are converting the electromagnetic field into mechanical energy. So this will respond only in the presence of applied magnetic field. So it is used in sensors for measuring magnetic fields and actuators for precise control in robotics. And the next smart materials are electrorheological or magnetorheological fluids. Fluids whose viscosity can be changed in character or composition by applying electric or magnetic field. So these fluids changes in viscosity according to the application of electric or magnetic field. So positive here if you see the electrorheological fluid, so when it was applied this is electrorheological fluid. So when electric current or magnetic field is applied, we can see the arrangement of these ions. So these are used in automotive and industrial applications to adjust suspension characteristics based on the charging conditions. Another smart materials are smart polymers. So the polymers that undergo reversible changes in their properties in response to an external stimuli are called the smart polymers. They exhibit tonic properties related to shape change, like to when an external stimuli is applied. Means the change in its shape. So if it is heated, deformed structure will be there. Again cooling, it retains its shape. They can be deformed into a temporary shape and then recover their original shape when recovered by specific conditions. The key aspects controlling shape memory phenomena in SMPs, smart polymers include polymer structure, activation mechanisms and the effect of modifications. So this causes a change in or deformed formation of a temporary shape and retain its original shape upon the release of the external condition or specific conditions. What are application of these smart polymers? So they are used in biomedical and magnetic field, medical devices, moisture sensors, pH sensors, also for drug delivery and even in the data storage and robotic skin and smart fabric, self-healing materials. So when the wound is there, to have the wound heal has to be having with the self-heal. So these materials are used to have the self-healing in the wound surface. And shape memory materials, temperature, light field, electric field, magnetic field, these smart materials or smart polymers are used and they have a varied application in all the industrial field. These responsive fabrics for applications like moisture management or color changing textiles are used in these smart polymers. The next smart materials are thermochromic and photochromic materials. Thermochromic, the name itself indicates the temperature. So based on the temperature, the change in the color. So photochromic, based on the light or heat, the changes its color. Here the photochromic materials are able to change in color when irradiated with visible or UV light. Upon exposure of this material to the sunlight, it changes its color. So thermochromic materials undergo a color change when heated above are below a threshold temperature. So generally the compounds are the substances the materials will have the polymer materials will have some threshold temperature. So on heating above and below temperatures, they change in its color. So these, for the best example is the color change of a spoon touching hot coffee because it is heat. So the change in temperature, because this spoon is made up of the smart material, specially called thermochromic or for thermochromic materials. So when it touches in the hot coffee, the change in the color of the spoon was observed, and with the cup is coated with thermochromic material, then pouring the hot coffee into the cup, it changes its shape, it changes its color. So if the rather than hot, if the cold water is added, it changes in color because low at heating are above and below the temperature causes changes in color. So the thermochromic materials are used in these cups and spoons. Coming to the next, photochromic lens. These are also used in the sunshades because these glasses when absorbed, here photochromic means on visible and UV light, when irradiated with UV and visible light, it changes in colors. We can observe the sun here white and black color because the sun, the presence of the cloudy means gray color and sun means dark color, and here this is white color. So depends upon the UV light and the visible light, it changes its color. The engineering application of these photochromic and thermochromic materials are used in the manufacture of smart windows. So these smart windows automatically adjust their tint based on the sunlight intensity. So the visible light, like sunlight intensity, these smart windows adjust because the glass material will have a layer of this photochromic substances. They will apply a coat of thermochromic substances on a layer of glass. They are called the smart windows. So these smart glass they are also called as intelligent windows. They are supplied to an electric current will be there. So they change according to the intensity of sunlight. They changes its color. We can see the example here. And next is the packaging. So they are used in the indicators as an indicators for packaging materials because they are temperature sensitive products. These thermochromic are temperature sensitive products. As we can see, as the temperature increases, it is changed to blue to red. So it changes in colors as the temperature increases. Suppose it is 10 degrees centigrade here. So blue color is like minus degrees, and when it is red, it is 15 degrees centigrade. So they change they change in their color according to the temperature. The next materials, like the last smart materials, are hydrogels. They are water absorbing polymers that can change their size and shape in response to environmental conditions. So they are used in wound healing or wound dressing and contact lenses and drug delivery and disposable diapers and tissue engineering and as well as in agriculture. So these hydrogels are used variedly in other fields. They are also used in 3D printing, actuators and sensors and artificial blood vessels, wound dressing and catheter coatings and implant coatings are contact lenses and drugs and molecular delivery and tissue engineering. They are water absorbing polymers. They are also polymers, but they absorb water. This is why they are applicable in all the different applications are there in different industrials. Then what are the engineering applications? They are used in drug delivery, wound care and tissue engineering due to the high water capacity and high water content and biocompatibility. These hydrogels are used. So these are all the piezoelectric or thermochromic or photochromic or hydrogels or shape memory alloys all have some varied and unique properties. So upon the action of the external stimuli, there may be a change in color or there may be a change in the shape. So they have unique properties. This makes the materials to use and in different innovative solutions across the industries. Here the engineering application of these smart materials continue because of their unique properties, and the researchers also expand and choose these materials to have a innovative solutions depend upon the applications across various industries. So this is like here we can see the change are the shape. These are shape memory alloys are used in the manufacturing of the wings of the these aeroplanes or aerospace compounds are used here. So this changes its shape accordingly. So these materials play a vital role according to their applications across various industries. And the another shape memory alloy we are going to discuss about is polylactic acid. Polylactic acid is a biodegradable polymer that has attracted significant interest in both academy and industry. These properties include biocompatibility, non-toxicity, and biodegradability. It is a renewable source, like it is obtained from the starch and sugarcane, and this is biodegradable and bioactive thermoplastic. This polylactic acid is chosen as a polymer with shape memory properties. So under shape memory materials, we are going to discuss about this polylactic acid as an example. It is generally prepared by the action of catalytic dimerization of lactic acid. So the precursor is lactic acid here. This is the starting material. So it forms a cyclic compound called cyclic lactate monomer. Upon the polymerization of this cyclic lactic monomer results in the formation of polylactic acid. Here the water molecule A will be eliminated and it forms a cyclic structure. Here the water molecule eliminated and it forms a cyclic structure, here minus H2O. So the formation of this cyclic structure, then the polymerization means, as we know, the polymer is nothing but a long chain of monomers linked together with a bond. It is called a polymer. So this is a biodegradable polymer. The monomer units are lactic acid, that is cyclic lactate monomers. They, upon the formation of chain, they are converted into polylactic acid. Generally, this is obtained from the starch. It may be the corn starch or sugarcane starch. They first fermented, the starch is fermented, then the lactic acid will be there. Then this lactic acid, obtained lactic acid is polymerized, and upon the manufacture of this polylactic acid, the products are used in tissue engineering, drug delivery, agriculture, automotive, and packaging. So this is, as it is a biodegradable which degrades the earth surface easily. This is used in so many industries like packaging, automotive, and drug delivery, agriculture, tissue engineering, because it won't release any toxic gas upon the degradation. As like normal non-degradable polymers, it won't give any earth surface. It won't give the trash to the earth surface. And the biodegradability, this is a biodegradable polymer and it is obtaining from the renewable source like starch, corn or sugarcane. Then coming to the properties of this polylactic acid or PLA. They exhibit properties that make it suitable for various applications. So first thing is biodegradability. It is biodegradable under the right condition, making it environmental and eco-friendly to the earth's surface. Next thing is biocompatibility. It is safe for use in medical and food contact applications and due to its biocompatibility. Next is the transparency. PLA is transparent and can be made into clear and glassy products. So the visually it will be like a transparent film. So this makes a clear and glossy products can be prepared with this polylactic acid. And the main thing is the renewable source. It is extracted from the renewable sources like corn starch or sugarcane. This makes these polylactic uses even more and applicable in different industries or different fields. And next thing, the rigidity. It offers good rigidity, means strong, and can be engineered in a small to be similar in strength to conventional plastic. So compared to the conventional plastic, the rigidity of the polylactic acid will be comparatively high. So this makes the lactic acid to prefer other than the conventional plastics. Coming to the next thing, which is one other best property is heat resistant. It has moderate heat resistance but may deform at relatively low temperature, limiting its use in high temperature applications. Coming to the brittleness, PLA can be somewhat brittle, which can affect its use in applications requiring impact resistance. Coming to the barrier property, it has reasonable barrier properties against moisture and some inert gases. So what are the uses of polylactic acid? So this finds an application in various industries due to unique properties. First and foremost step is packaging. As it is biocompatible and even it won't give or it won't reacts with the food materials, and due to this biocompatibility property in package industry, it is producing PLA is used for producing biodegradable and compostable packing material such as disposable cups, food containers and films to pack the food. This coming to the next application, which is textile industry. The PLA fibers are used in the polylactic fibers are used in the textile industry to produce biodegradable and sustainable fabrics. Coming to the another application like medical and health care, this is used in medical devices such as sutures, because sutures is to heal the wound. These polylactic sutures are used, which can degrade in the body itself without causing or without infecting the area. And tissue engineering scaffolds and drug delivery systems due to its biocompatibility. So it is used in textile industry, food packaging, all these industries. This polylactic acid is used agriculture and even in ear implants. This polylactic acid is used. Coming to the next application, which is the 3D printing. It is a popular material for 3D printing due to its uses. It is very easy to use and biodegradability and availability in various colors. Coming to the filaments, it is used in the manufacture of filaments for fused deposition modeling 3D printers. Then biodegradable films are used for agriculture applications such as mulch films, and they can be plowed into the soil after use. So these disposable tableware such as plates, bowls and utensils for single-use application, as it is biodegradable for single-time application, these PLA plates, bowls and utensils are preferred because of this biocompatibility and biodegradability. And consumer goods can be found like toys, cutlery and cosmetic packaging. These PLA films or PLA packing materials are used. This is all about the polylactic acid, which is one of the shape memory material, comes under the category of smart materials. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.